All right, everyone. Well, we're at the top of the hour, so we're going to go ahead and get this webinar started. I just want to start by thanking you all for taking the time out of your day to join us while we cover this exciting topic on SOLIDWORKS Electrical, where we're going to focus on harness, design, and documentation. So this is really kind of a first for me, this being that this is my first, I guess we'll classify it as my first webinar under quarantine. So hopefully all of you guys are faring well during these crazy times and staying well and staying safe. Here I did want to put out a disclaimer. Not sure how many of you can relate to this, but I got three wild, crazy kids locked up in a bedroom upstairs. So my wife's doing her best to keep them quiet, but you know, bear with me should we hear any background noise. All right, well, let's go ahead and get things started. So a little housekeeping as we get going. So for those of you who are not familiar with webinar, our GoToWebinar, in your panel on the right hand side or wherever you've docked that, there's a few options that I would like you to look at. First on is viewing in full screen. That'll give you the best experience. And then also, we will be taking questions throughout this webinar. I have my counterpart who resides on the East Coast, JP Emmanuel. He is a technical manager of the electrical products as well. He is online and he will be answering questions as they come in, and then as we have time at the end, we'll do our best to field questions then. So as they come up, feel free to shoot your questions out. JP will be answering those live, and we'll see what time we have left to address any more. All right, so moving on, I just wanted to show a little bit of success stories that we have behind our product. So the first one that I wanted to talk about is a company called Shred Tech. Now, Shred Tech was able to, transition from a standard CAD tool over to SOLIDWORKS Electrical, and with the ability to auto-generate their reports and their bill of materials, they were able to, drastically reduce their design time down from 5 days to 4 hours on that documentation. So a great success story there. There's a web link if you are interested in learning more about ShredTech. And another quick success story is Applied Robotics. So Applied Robotics adopted our solution, that is both our electrical schematic solution and our 3D add-in for mechanical, electrical 3D. And with those combined solutions, they were greatly able to improve collaboration and efficiency for their products. Now, another thing I want to mention before we get into things is talk about a challenge that we did. So we threw together what is called the schematic challenge, and this was, just a concept idea to just show users exactly how much time can be saved when transitioning from a standard generic CAD tool to more purpose-built intelligent tools such as SOLIDWORKS Electrical. So in this side-by-side study using the same symbols and data sets, we saw that SOLIDWORKS Electrical was 3 times faster. So SOLIDWORKS Electrical was able to complete the project in 16 minutes versus 50 minutes in generic CAD. So we have a whole webinar where you can watch this content if you're interested as well. But getting started into the reason that we're here today, I'm going to start with introductions. My name's Thomas Smith. I am a technical manager with SOLIDWORKS, and I focus on our ECAD products, so SOLIDWORKS Electrical, Electrical 3D, etc. I reside out of Denver, coming to you live from a small town just northeast of Denver called Fort Lupton. Working with JP, both of us support North America and, all the electrical related matters. Prior to coming on with SOLIDWORKS Electrical, I spent many years as a designer in industry. I worked and consulted on multiple CAD applications specific to ECAD tools, owned my own business for a while, and I've been with SOLIDWORKS for about 1.5 years now. So a little bit about my background. But the reason that we are here today is to talk about harness design and documentation. And, really, when we get into this topic, I think it's important to understand what the problem is. Why are we looking at purpose-built tools? Well, the problem is 50%. 50% what? Well, we find by talking to our customers that they state that 50% of their engineering time is spent doing manual, repetitive tasks, which are often error prone, which in the end cause delays and are very time consuming. So we are going to look at how a purpose-built tool and such as SOLIDWORKS Electrical can, increase your efficiency, allow you to complete your projects quicker, with more accuracy, and just get your projects completed on time. So talking today, we have several areas that I want to focus on when it comes to SOLIDWORKS Electrical and purposes of harness design and documentation. As you can see from this slide, there is a lot that I look to cover in this. I think a good spot to begin for those of you who are relatively new to SOLIDWORKS Electrical and what it is, I thought we'll start with a quick overview of the tool. So SOLIDWORKS itself, falls in just greatly into the overall Dassault systems of solutions, and specifically into the SOLIDWORKS ecosystem. So where we can have our electrical design, our 3D, 2D CAD, collaboration, all under one ecosystem of SOLIDWORKS, where they can all communicate and work efficiently together. Now diving in a little bit more into the typical design process. So as I stated, when we looked at that schematic challenge, and I said, our customers are using standard generic CAD tools. Well, in this typical process, we're doing all of our design work first, our logical definitions, our part selections, etc. Once all the schematics are created, we transition into, the generation of our reports. And typically this is done external to the application. So it's a manual process of taking the information from the schematics, translating it into, in this case, Excel. Once that's done, we're going to move over to the audit process where we're, making sure that we're catching all of the errors and that we're ready to go to production. When those errors are found, we repeat this process and continue to go through this phase of updating the schematics, manually updating the reports, going through a design review until our, project is finally complete. When we bring in SOLIDWORKS Electrical, we look to add efficiency in two areas. With our purpose-built tools, in this case, the tools that we have for designing harnesses and cables will add efficiency. But where you'll see a lot of return of your investment will come in the reports, where SOLIDWORKS Electrical can automate a lot of those reports that you guys are very time consuming, manually having to work on inside of Excel. We can auto-generate those reports, keeping those error-free and ready to go quickly. So what's the driving force behind SOLIDWORKS Electrical? Well, SOLIDWORKS Electrical is a database-driven application. In fact, it's a SQL database that is driving everything that's happening behind the scenes. And part of that SQL database is what I refer to, or what is the shared library. And this is really where a lot of the intelligence comes out of our tool. We manage these libraries on a server level. And so all users who are interacting with the application have access to the same data. And all of the data inside of the library is accurate and up to date. And it carries a lot of great information inside of it that is pushed out throughout the design as these library elements are utilized. So in this case, as we look on the screen, what we're going to see is a library entry for a connector here. And as I stated, there's a lot of information that's contained in just a single part number in this instance, whether that is going to be our graphical representations, our one-line symbols, schematic symbols, 3D and 2D layouts are all contained in there. In addition to that, we also get circuit information that can be contained within the circuits and terminals. So there is a lot of metadata that is contained in the library. And as these library elements are utilized, all of that intelligence is pushed downstream and managed by the application. Through the use of these intelligent libraries, it helps us add and work with standardization inside your organization, again, given that everybody is accessing the same data. Now, why is that important? Well, it's important because, as you guys are aware, as you are working within these tools, is that a single device or a single symbol actually contains a lot of data. When we look at this power supply that I'm showing on the screen, there is a lot of information that's associated with that. Marks, terminal numbers, manufacturer's part numbers, current ratings, wire numbers, etc. And not that information is not just maintained within the symbol, but is also populated downstream, which in this case is reports. So you can see from this simple graphic how, having to manually manage the change in just one symbol, what the downstream impact of that is. And it's really easy, to catch an error. I have typed power supply 510 alpha so many times through my manual process that I didn't realize when I went to print my labels that I fat fingered it and typed it in as power supply 501 alpha. So, these are things that our application will help eliminate because of that library-driven intelligence and the associativity built in. So, in conclusion, SOLIDWORKS Electrical is a purpose-built schematic design tool that allows you to design your systems quicker and error-free. We can handle your schematics, whether that's a single line or multi-line. We can do electrical, pneumatic, hydraulic, and P&ID. We have intelligent components, intelligent symbols, wires, and cables out of the box, ready to work with. We can handle your layouts, whether that is going to be a 2D layout, a 3D layout, utilizing electrical 3D. And then, again, the most bang for your buck is going to be in our reporting engine. So we can auto-generate your system reports. We can even run design rule checks, which is a design audit as you're working within your project to catch errors and run various calculations as you go. So in the end, you can see, almost upwards of 50% of reduction in documentation time. Because of the library intelligent tool driving behind the scenes, we can nearly eliminate human error. And with the integration into mechanical, we can enable the collaboration between both your electrical and your mechanical teams. All right, so that's a little bit about the overview of our product. Another thing that I want to point out is multi-user collaboration. One thing that is very nice about our tool versus other packages out there is that our tools allow for the engagement of multiple users at the same time. So with our collaborative server, we can have multiple electrical designers working on the same project at the same time, while the mechanical counterpart is also interacting with that project. So I mean, that is a very, very powerful tool that we can have multiple users collaborating simultaneously on the same project with our application. All right, so let's get in and talk more specifically about harnessing tools. So when I talk about harnessing tools, there's three areas that I want to focus for this purpose of this webinar. The three items that I want to look at are dynamic connectors, some harness management, and a feature that we call connection labels. So dynamic connectors. What is a dynamic connector? Well, in our application, a dynamic connector is this. Now, it is not a static symbol as what you're seeing here, but by the term dynamic, it allows me to specify how I want this particular connector configured on the fly. And so we can build these out, adjust the pins as we need them, place what pins where we want them, etc., all with our dynamic tool. So it allows us to build them based off a manufacturer's part and circuit information and design them specific to that project as needed. Now, one thing what's nice, and I talk about standardization a lot, is within our tool, it kind of forces standardization within your organization. And when we talk about using a dynamic connector or using our connector tool, one of the great things is that we can set these configurations. So we can have connector configurations that are going to be stored either on an application level or project level. And these configurations standardize things such as the appearance, the physical appearance of the connectors as they will be placed. What is the radius is going to be? Are we going to include combs, etc.? And another thing is, we can also specify the circuit information. If we wanted to have any representations of circuit elements inside of the connector, we can turn those on here as well. So this is a way to create custom connectors in different styles and configurations, but again, have those available on a networked environment so that all users, when they're creating and generating dynamic connectors, are doing so with the same information. So, when it comes time to creating a connector, we have on our schematic tab, we have the insert connector tab, or the insert connector command. And what's nice about this command is, as I mentioned, as soon as we click this, all of the intelligence that we're driving for this connector is driven by manufacturer's database. And so when you see in this graphic, as soon as I go to create that connector, I can select the manufacturer's part that I want. And based off of that manufacturer's part, it's going to bring down all the terminals and pins that are associated to that manufacturer's part. And based off of that selection, when we come in and it's time to place it, and we have our actual insert command and we're placing our dynamic connector, we can work with these tools to actually define how that connector will be placed. What configuration are we going to use? How are we going to handle breaks? You know, if we choose to break it here and continue in another location, what pins do we want to place and what orientation of the symbol? All of that drives down to allow us to create a very clean, intelligent connector, again, all driven off of that library management system where we can customize pin placements, etc., all doing that on the fly. All right, so, you know, getting in and talking a little bit more about harnesses. So we can obviously create intelligent connectors, and we have intelligent wires that we can work with inside of that. But what tools do we have more specifically, you know, in relation to harnesses? So the first thing that I wanted to talk about when it comes to, you know, managing and working with harnesses is some of the tools that we can find within our project database, such are our project tab, such as working with our cable manager and our harnesses. So a cable manager, oops, got a little trigger happy there. My cable manager allows me to specify and manage the cables on a project level. So in here, I can come in and add cables based off of manufacturer's part numbers and information. All of these cables, again, are coming out of a library that is that is maintained and available to all users. So in this case, you know, once we assign the manufacturer's part information, all of the conductors in this case are driven out of that database. And so, you know, once we do that, then we can come in and start further managing those cores and associating those cable cores to their appropriate wires out in the actual project. And then so we can manage our cables, we can assign our cable cores to those and apply those to the actual wires. And then in addition to that, we have harness tools that allow us to, you know, manage what is included in each harness that we might have within that project. So we can understand what line diagram symbols are available, what wires are included in this particular harness, cables, references, and components. Now, this is very useful information that you can have. I mean, when you're in a disconnected CAD tool, you're relying on, you know, your manual stuff and your brain to remember, you know, what is included in which harness and, you know, et cetera. So having these management tools, understanding, you know, what cables are being utilized, what conductors are we assigning, you know, for those, what wires are going to be included in that cable, and then being able to manage all of that information particular to each harness is a very valuable tool. So we have some management tools that will allow us to document those nice, but how do we handle more specific things like when we come in there? You know, it comes up a lot, you know, twisted, shielded pairs and splices. So when it comes to twisted and shielded pairs, you know, we work with those as we do any other symbol. So you can create a schematic symbol to represent your twisted pairs on the schematic in any version you want. We have some out of the box shielded pairs that we can use. We can also include that in our cable information if we wanted to show that we have twisted shielded pairs there. So there's multiple ways that we can represent those schematically and making sure that that information is getting pushed out into the bill of material. Splices are handled very similar. You know, they are going to be represented by a schematic symbol. So that schematic symbol, you know, is just like any other schematic symbol. As soon as we place a schematic symbol, you know, it's going to get its tag based upon the tagging properties that are set up, and we can also associate manufacturer's parts to that. So, you know, we can handle both, you know, twisted shielded pairs and splices, no problem with our schematic tool. Coming on, now we also have connection labels. Connection labels are a great way of displaying information quickly on your design. So these are going to show the representations that are associated to any given or associated connector. So in this particular case, I could quickly and easily place a connection label next to any connector that will show the pins, the destinations, and wire links. Now these are customizable blocks and symbols that you can place to look, a variety of ways. But these are a quick way to get the information out onto the schematic, onto your layouts, and have the information readily available. Connection labels can be placed in line diagrams as well as schematics. We can also place these in layouts, and I will be showing that here in a moment as well. So we have multiple ways in which we can place and areas in which we can place connection labels. As I mentioned, connection labels are intelligent symbols that are built in. So we have a library of connection labels. You can have as many as you needed for the various connectors that you would like to document. And you can get different information depending on the connector that you select and the connection label. So let's go ahead and take a look at a little bit of all of this in action. So here in this schematic, I got my harness project. I already have one harness schematic being done, but I'm going to come out here to a new one. And so within this schematic, I'm here on the schematic tab. I have the insert connector here. So in this case, I'm going to define a new connector. As soon as I define a connector, it's going to want me to look for a manufacturer's part. So I'm going to locate that manufacturer's part that I want to drive. I got a 25 pin connector here. So I'm going to go ahead and select that. It's going to give it its tag based off of the properties. Now I'm going to come in here. Now this is where the dynamic portion comes in. Here I can select any configuration that I want to work with for this particular project. So I've selected that configuration. I got various options of how I want to draw that. There's the 25 pins that I had selected. You can see by orientation, it's coming in a little backward. So I have the orientation icons. I can flip that. Here, I'm going to come in and specify exactly which terminals I want to place at this point in time. So I'm turning on the specific terminals that I want to see, and I'm going to come over and place those. Now, it's automatically going to show which ones I have placed and only give me the ability to place the remaining connectors. So I'm going to come in and go ahead and place the few connection points and pins that I want to place for the remainder of this connector. So again, this is a fully intelligent system. It's all driven out of the library information. Now I'm going to create a new connector, but you can see here it gives me the ability to continue on the connector I was just working with because I didn't place all those pins. But in this case, I'm creating another new connector on the other side. So I'm going to go ahead and quick and do some filtering in here within my library. All right. So I got my connector. Again, I'm just going to do some orientation flipping here to get it in the appropriate orientation and select my pins for this particular one. So I'm just going to turn all these guys on that I want to use for this particular design. All right, I'm just going to go ahead and place my connector. And I'm going to come down here, finish selecting the pins that I want to place for this second portion. And I'm just going to locate that out. All right, so I've placed my connectors. Now I'm going to go ahead and I need to throw some wires in here. So I have my intelligent wires, which are driven off of, again, a library, a database. So all of these wire styles have intelligence into them. And I'm going to just quickly pull and connect those wires over. Now I want to talk a little bit about, the case of where we actually have a manufacturer's part and we got this connector, but there's a lot more information that we want to include for this particular connector. So I'm going to add the additional components such as the back shells, the tape, etc. So I'm just going to find a few more manufacturers that I want to add all the critical components that I want to make sure are represented on the bill of materials here. All right, so here I'm going to add 2 spring latches. I just increased the quantity over there. Let's see, I'm going to go ahead and add the back shell. Here I'm going to go ahead and add a few more parts, look for TE connectivity. Find my particular ones. Let's see, I need to go Okay, here we go. So I'm going to add my back shell tape and my sleeve. And then the last thing I want to throw on here are I want to add my pins. So I had 25 pins, and I'm going to go ahead and type in my manufacturer's part number. And I'm going to increase that quantity to 25. All right, so there I have all the information that I needed, for this particular connector. I'm going to go ahead and hit OK. Now, one thing I want to show is, so, I have a detailed and intelligent schematic, but what if I also want to show this on an, kind of a single line or a harness overview? I can do so. So this is a one-line schematic. Again, it allows me to create that high-level, intelligent overview drawing. So what's nice is over here, you can see I have all the components that I've placed. So I wanted to relate this particular line diagram to a symbol that I've already placed. As I go through these components, I can easily select that related component. So this is no longer a new connector, but becomes associated with the connector that I've already placed, receives the same tag, and everything. And as you saw, all the manufacturer's database or manufacturer's parts information was included in that. So I'm going to go ahead and associate this particular connector to another one. Again, I have visuals here to ensure I select the appropriate one. Given that this is an overview drawing, I'm going to quickly place in a cable here to connect these two particular connectors. So everything is intelligently and associatively linked between the single line diagram and my schematic. Now let's talk a little bit of managing those cables. So I'm going to come to the project tab and open up my cable manager. Here you can see I have several cables already added to this, one of those being the quad twisted shield cable. So down here in my schematic, I got these 4 wires that I would like to associate to that cable. So I'm going to easily and quickly select those wires, and I can come up here to associate cable cords. That brings me back into my manager, but under here I can locate that particular cable that I want to associate these wire cores to. And with the tools that are built into this and the intelligent management tools here, I can easily and accurately associate the appropriate cores within that cable. And so that gives me all the intelligence to know that those 4 wires are in that particular cable. Now I have different various labels and things that I could put on these, etc., to help that. But let's talk about, those adding twisted shielded pair representations. As I mentioned before, these are, we can represent these with schematic symbols as well. So out of the box, you're going to get a variety of various symbols that you can use. You can also easily customize and create your own symbols if you wanted to create any variations of those that you want. So again, intelligent symbols, it's automatically getting tagged. Just going to add another one here on the opposite side. Just specify my specific wire type.
Hey, Thomas, can you just slow down your mouse movement just a hair? Just because a little bit of lag in the system and it's just kind of jerky right now.
Yeah, I'll do the best that I can. So I apologize if the screen is jumping around. Could be due to some connections. We got quite a few people connected on the webinar today. But yeah, I'll do my best. So here I'm just locating a splice in this case. I'm coming down and placing my splice symbol, handled as any other symbol is. At this point in time, I am going to add a manufacturer's part to represent my splice. And I can just go ahead and wire that up. All right, so I've represented, my twisted shielded pair and also placed in my splices. So I got all of my various components, but here I'm going to go ahead and add a connection label. And so as I mentioned, a connection label is a quick way for me to, get the information related to a specific connector. Standard symbols that you can grab from your library, I'm quickly going to grab just a standard 6-pin connection label. Now, right now it wanted to tie it to, just a new symbol, but with my intelligent tools over here, I can link it to an already placed element. So in this case, I'm going to my X44. Now that changes to X44 and populated all my destinations for those pins. And it's easy to place these on. You can place them anywhere. I'm just, for purpose of demonstration, going to throw another one down here and link it to another component. So this time I'll go to X43. And again, you'll see the destinations and everything are updated for X43. Now you're not just limited to putting connection labels on the schematic drawings. They're very flexible. Here on the line diagram tab, I can also insert another connection label and be able to place those and relate those back to those components. So again, just a quick and easy way for you to get that information out as needed, particular to those pins. So the last thing I wanted to come and take a look about real quick is to come over and take a look again at that harness information. So here I have one harness under this project that's already defined, and you can see I have no elements, no wires or line diagram elements. So here I'm just going to quickly make some selections out in here. And once I get all the elements that I selected for this particular harness, I'm going to right click and I have the option to add or remove from harness. So in here, it is allowing me, to make sure I got the appropriate element selected, which in this case I do. I select my harness, and now you'll notice that when I come back into the harness manager and I expand H1, I got all the wires that were selected, the cable that was selected, and then also all of the components. So the software understands from a management point just what is included in that particular harness. So that is a lot of powerful tools when it comes to creating and managing intelligent schematics. So now let's come and talk about what options we have for creating layouts. When it comes to creating layouts, and we're focusing solely on our 2D for this particular webinar, we can create two types of layouts. So we can create a layout drawing and a mixed schemes. And really what these have to do with is the type of drawing that is driving behind the scenes. So the first one we'll talk about is a layout drawing. And so the way that a layout drawing works is it is created off of a typical layout template. So this is going to utilize the layout environment, the panel layout environment that's built in for SOLIDWORKS Electrical. But what's nice about when we work in the layout environment is you can see over here we get all of our cabinet layout tools, but we have this components tree over here, and this will allow us to access the components that have been placed in the schematic and then quickly get those into our layouts. All of the information is being fed intelligently by the library. So we've already placed the one line and the schematic symbol, which both carry a part number, which based off of that part number, I can get in there and quickly create that layout, as I'll show here. So when we have a manufacturer's part number in our database, one of those things that I showed you earlier, and I'm showing you again here, is that we can map certain symbols to that particular part number. And in this case, what that allows us to do is quickly go over, select the component that we want to insert from our component tree when creating our panel layouts, select insert, and that symbol is already mapped to that. So we can continue to place those elements and draw our documentation for that harness. So a layout drawing, again, works in the layout environment and works with our component tree to place those, more of a panel footprint side of things. We also have mixed scheme drawings. A mixed scheme drawing is really the same type, except we're working more on a schematic sheet. So we have, we're working with schematic symbols instead of layout symbols in this case. We can still work with wires and lines and have all different types of blocks and symbols that we want to fully document this design. And again, guys, I apologize for whatever is happening with the mouse movements. Hopefully the recorded version of this webinar isn't experiencing the same lags that you guys were experiencing before. So similar in the mixed scheme, again, the only difference is the drawing type that we are going to be working with here. We have a components tree based off of those manufacturer's part numbers. As you can see in this graphic, we can automatically place the symbol representations that are associated to those. So again, these are just intelligent tools that will quickly allow us to document it, all being fed off of the manufacturer's parts. All right, guys, so here again, I got that same schematic that I was working on, and we're gonna quickly create um, a layout for this guy. So here I went and created a panel layout. And as I mentioned over here on the right-hand side, I got a components tree. And in here, I can see all the various components that are going to be represented in here. So what I'm going to do is right click, and on this guy, so I'm just going to show you the properties real quick. And we can see, that the manufacturer's parts inside of it. All I had to do was right click and insert. And based off of that intelligent library, I was able to quickly place that connector and really not have, to search a library or understand that. What's nice about this is the associativity that is also included in this. So if I change anything about this component in any place, it's updated. Now here is a nice tool. I just hid everything that hasn't been inserted so that I can only work with what needs to be placed. Now here, I'm going to quickly delete that symbol out. I'm going to add a new connection label. I just wanted to show you guys that the connection labels can be added in this environment as well. So we can also represent connection labels within our layouts. Again, these quickly get the information out regarding the connections particular to that connector. So as you can see, as I quickly fill in that information, it populates there. Now, as far as the lines and anything else, we have our standard drawing tools that we can use within the application to work with that. One other thing nice I wanted to show for those of you who don't know is we have a direct integration with our CAD product draft site. And so if you ever had any design drafters that you wanted to come in and document anything that's associated to your project, a drafter could come in and work on any annotations. Again, this is still intelligently linked to your project, but is not consuming a full license of electrical if you had some drafters that you just wanted to come in and detail those out. So what I'm showing in here is quickly, went over to draft site. I'm going to save that. So my drafters added some dimensions. I'm going to come back over to electrical and I want to see, what they've done. So I can update that and there's dimensions. So as far as getting the harness layout in there, we can do the intelligent symbols, we can draw out the wires, etc. Using drawing tools. The links are still going to be manual in this process. We don't have anything that is giving us the links yet through a 2D application. So whatever means you guys are doing to get those links, those will still have to be manually added. But what I'm doing inside of here is I'm in a schematic drawing. And what I'm going to show here is I'm using a standard blocks. So these are CAD blocks. Maybe you've already defined these or drawn these, but I'm just going to go ahead and quickly place blocks to help me better document and detail this particular drawing. So I got my flyout that I'm going to put in here. And now I'm going to come over to my component tree. And here I can see I have my J1. I'm going to go ahead and insert my schematic symbol. Again, you can see that this is all being fed by the library. I didn't have to choose it. As soon as I selected J1, all the intelligence that was created and defined in the schematic is also represented here for J1. You can continue to create as many schematic representations that you want or symbols that can be associated to the particular connector to make it represented the way that you want. So I'm just associating the front view to J1 as well. What's nice about working in any of these CAD tools is we can continue to place and work with blocks that you might have used to further detail. So I just have some blocks that I'm going to put in as far as a splice detail and a twisted pair detail again. So I'm just going to specify some details right here. Here I got my splice detail. As soon as I place that, it's got intelligent attributes. If I wanted to, I could populate this information in here. So I'll just throw some values in here real quickly. And all right, let's come in, continue to specify this symbol. All right, so as you can see, we just have some generic attributes that I'm going to throw in here and populate that. So we can, through the use of the intelligent schematic symbols, connection labels, blocks, etc., we can add those. Even if you want to add text, we got text with leaders that you can put in, and whatever documentation that you need to accurately get these documented. All right. And so I'm going to go ahead and let's see. The last thing I want to do here is quickly add another connection label. Again, just showing the value and the benefits of this. Just going to change the type of connection label that I'm going to place here, and go ahead and select that and get that in placed in there. All right, so there we've talked about our layouts. One thing, we're getting close here on time. I want to talk about our reporting engine. Again, this is where I think a lot of people will find value. So here, because of our intelligence that's built in, we can automate our outputs for those drawings. We can create Excel, PDFs. We're a SQL database driven system, and we're fully configurable. So we can create and modify our reports to look the way that your company and your organization needs them to, to look, so that we can get those manufactured as quickly as possible. Now, not only do we have reports for generating bill of materials, wire and cable reports, but we can also run what are called design rule checks, and they will allow us to catch errors as we design. So instead of waiting to the design review, we can start catching these errors earlier and live as we work through our project. So this will help us reduce design time for design review. And also with these, we can run not only can we look for errors, but we can also, look for and run various calculations. So let's real quickly take a look at our reports. So coming in here, got the schematics and layouts finished. I'm going to come over to my project. Here I want to take a look at some of the design rule checks. I'm going to come in here and look we have several out-of-the-box design rule checks that you can select. All right, there's a lot that comes with the software, but you can only, you have the ability to only assign design rule checks to a project that you want to use. Anything that has a list in here has an error. So, here I have several wires that haven't been marked. If I wanted to do voltage drop and I had that information in there, I could run those calculations. But I have some errors. There's errors, and it listed those errors to me before I went to design review. So now I'm able to go back into my design and catch those errors. And just real quickly to show you what it's done, if I come back here to wires without mark, you're going to see that all of those are removed from the list. So once I've verified all my design rule checks have passed, now I can come in and generate my reports. So we got various reports. You can see as I click on these reports, the different formatting that will be displayed, different properties that are being tracked. We have the ability to export and to generate those drawings. As I mentioned, these are highly configurable and customizable reports. So, we can change the layout, what columns are going to be displayed. We even have the ability to get in there and customize the actual SQL query as well. So highly customized report. When it comes time to generate and run your reports, we can do so with the click of a button. You just select the reports that you want to run, click the button, and your reports will quickly and accurately be generated. Again, all of this information is being fed from the database. All right, so we get notification that those reports have run. We'll just quickly come out here and take a look. So here's my bill of materials grouped by manufacturer that I set. And then I'm going to take another look. Yeah, another bill of materials, and then we'll come down and look at list of connections. And we can come down, cabling reports, etc. Again, all I had to do was hit a click of a button, generate drawings, and my reports are up to date based off of and being fed from my schematic. Now let's talk about another thing that I'm sure a lot of you can relate to, and that's having to deal with change and understand how that impacts the amount of work that it's going to take to do that change. What's nice about our environment is that we are fully associative. So everything, as soon as it's placed and related into the project, is connected. And that allows for us, so that we make a change one place, it's automatically updated to the other references. So this is going to remove all of our manual work. Now, what does that actually mean? Well, so, within a project, we got various elements, our single line representation, schematic, layouts, and reports. And, with our SQL database that's driving that and the associativity of SOLIDWORKS Electrical, we can keep those all linked and integrated together so that when a change happens, say the change is happening in this schematic, that change is updated to each one of those elements. And so because that intelligence is being driven by the tool and no longer having to rely on the human, we can really speed up that process. So let's take a look at that real quick. So in this particular example, I have the reports already ran. I have a cinch there. I'm going to come out here to my manufacturer's part and I'm going to change that cinch. So I'm going to remove the cinch as my connector. I'm going to remove that off and add a new connector. So I'm going to add a Deutsch connector. So I've switched out the connectors. I had a 25 pin cinch on there. I'm going to locate here in a second, if I can get in here, base, that'll help refine that. I have a 20 pin connector here from Deutsch. So I also had 25 pins on here. So I'm going to remove 5 of these pins. If I can count here. All right, so I've updated that. So this manufacturer's part has been updated on the schematic symbol. All of the text and everything has updated for that particular change. Now, if I come back and look at the one line, you're going to notice that all those manufacturer's parts have been updated automatically. So that's nice. But let's go and update our reports to make sure that all that information is up to date too. So very quickly, as you can see, I'm going to regenerate that report. Just a click of a button. And now my report has been updated, so let's go ahead and take a look at that bill of material. Now you'll look at cinch, you're going to notice that X43 has been removed from there. And if we come down here to my Deutsch, you're going to see that X43 and X45 have now been listed with that new part number. So all of that change happens automatically and is managed by the software itself, all through that intelligence database that is driving. Now, in addition to having all of these out-of-the-box tools, intelligent connectors, intelligent libraries, one-line symbols, wires, cables, harnesses, we also have the tools that allow you to take your design to the next level, such as, in this case, Excel automation. So if your organization, has any designs that are similar in nature, then you can take advantage of Excel automation, which is the driving and the creation of your electrical projects based off of a configured Excel file. So if your projects are similar in nature, so similar but different, and reused frequently, then you could be a candidate for Excel automation. And Excel automation can also work with harness drawings as well. So anytime we automate things, this further allows us to save time and money and reduce errors. And again, all of this is being done by an intelligent spreadsheet. So this is just some added value. Again, this is a functionality that's available out of the box as well. But here I'm working inside of, in this case, is Google Sheets. So I have a particular form that I would like to fill out for this particular project that I'm going to create straight from Excel. So in here, I'm just inputting some information real quick that I want populated for my project information. So coming out and again, just populating some names. What template do I want to use? We'll stick with our ANSI. And we'll just put in, again, a couple more details, functions, and then I'll come down. I got some drop downs here, which is really nice. Now, this is a form-driven thing, so in the background, as I make changes into the selection dialog box, it's driving another Excel sheet, which has all the data that SOLIDWORKS Excel will use to generate and create this project. All right, so I'm just going to download an XLS. Again, that is the only requirement, is that we got to have the Excel spreadsheet, whether you use Excel or Google Sheets, etc. So here I have a new project that doesn't have anything in it. I'm going to come over here to import export, and I'm going to grab the Excel file that I just downloaded, and we'll get that guy in. And so you'll see it's bringing in, it's reading that Excel file, making sure that all the data that was listed in there is back. It's going in and inserting and creating these drawings. You'll notice over here that it has created some new books. So we got a schematics and a 4D. It is telling me that this has finished. If I open my schematics, you can see I got a bunch of files that were created. Now this was customized based off of that Excel spreadsheet that I filled out. So exactly, what is going to be shown on the one line, what connectors will be included in the schematics. So all of that information is very and highly customizable, driven by Excel. So just a little preview of that. Now we also, while this webinar focused on 2D, we have a 3D integration as well. So I quickly just wanted to talk about our 3D integration. So with our electrical 3D add-in, we can seamlessly bring in our electrical and connect that to our mechanical and fully represent our projects, all the way down cables, harnesses, and wires that can be shown and represented in our mechanical environments. Now, what is nice about this is a two-way communication. So as you can see in this example, we have, our electrical schematics over here on the left, and this, well, in this case, it's a PNID, but it's still being shared back and forth. Whether it's driven from electrical or driven from mechanical, we have a two-way communication. So here we'll just take a quick look at this example in 3D. So here we have the electrical 3D tab. It's got some useful tools for routing wires, cables, and harnesses. I'm quickly going to open one of the harnesses that was routed with electrical 3D. So here I got my harness. I have the ability, once I'm inside of mechanical, to utilize all the powerful tools that mechanical has. So here real quick, I'm going to create a flattened annotation of this particular harness. So it's going to go ahead and flatten that out for me. Once I'm inside of mechanical, I do have various tools that I can use to edit the route. I can change the flyouts, move connectors, flip, and associate all of these things. So very powerful tools. Again, with the integration into SOLIDWORKS, we can quickly create our documentation. So I have create drawing here. When I have options, do I want to include a BOM, cut list, connectors tables, do I want to have that automatically ballooned, etc. So these are, selections that you can make on the fly. I'm going to go ahead and create that drawing. So it is automating the process of this for me. So it's going to tell me that I needed to add some link fields to my bill of material. I'm going to say okay. Now, as you can see, it allowed me, I put in this bill of materials here. I'm just going to quickly snap this down over here on the left. But once you're in SOLIDWORKS, you have all the power of the SOLIDWORKS drawing environment at your disposal. So you can further document and detail this to whatever degree. All these balloons are adjustable, the flyouts are adjustable. But what's nice is we have all this integration to electrical. So right here, I clicked create project drawing. And what it is doing, it is taking this mechanical drawing that was laid out and inside of mechanical, but it is feeding that information back to my electrical. So I'm just going to hit OK real quick. And I just want to show you guys when I come back into electrical and in my project tree, there is, the harness that I imported from SOLIDWORKS. So in conclusion, SOLIDWORKS Electrical can help remove manual work. It can save you time and help you reduce errors, all the while creating very accurate, detailed schematics and harness layouts. So at this point in time, we do have a few minutes left. I greatly appreciate your attention. I apologize for any audio issues we might have been experiencing or lags, but I will open it we'll take a few questions here at the end. JP?
So, I have not stopped typing for the past hour. Lots of questions, awesome questions. One of the big things I've seen, first and foremost, yes, this is being recorded, and tomorrow at 1 p.m. when this webinar started, you should receive another email with a link to this webinar. Now that we got that out of the way, the second one is manufacturer part information. How can we get manufacturer part information into the system? How do we create manufacturer part information? Who can see manufacturer part information? Who can control it? So if you want to touch on a couple of those aspects of it, mainly I think the biggest one we've seen is bringing that information in or manually creating it. So maybe open up a part and show the metadata fields in there. That's what's available to start.
Yeah, definitely. So I closed down here real quick. Let me get up and running, and we'll talk about a manufacturer's part. All right, so within our library, and we come into manufacturer's information, we have the ability to add a part right here. So if we wanted to create or insert, a part from scratch, we can add a manufacturer's part. When we add a manufacturer's part, this is the information and the metadata that JP was mentioning. We can specify obviously all of the reference informations, descriptions, supplier information, even the physical properties, tell it what symbols. We can also define, what circuits are going to be associated to that particular manufacturer's part. So we can create these on the fly by utilizing add manufacturer. You also have the ability to import information here as well. So we have the ability to import from an XLS if you had part numbers. We also have a content portal. So we have an online content central where you can come into this. So we ship with, a handful of manufacturers' parts, and there's hundreds of thousands when we get into our online content portal. So you can come in here and you could type in, any manufacturer that you want, and you can see, we got 133 million part numbers up here and various different, manufacturers. So if you wanted to download something from one of these manufacturers, you could simply, just locate that, and then you can download that and bring that data into your application. So simple downloads, of connectors, like we'd say here. That downloaded, I could come back into electrical. Here I could unarchive, find my download, and open that. And so this would import, those various ways. So we can create new parts from the fly. We can grab parts from our online content portal, and we can also import from an XLS. So hopefully that answered the question. Now to talk about, who has access to it. So this is library-driven information. So we're putting all of this data into our library, which is going to be stored on the network, and all users have access to that information immediately. And we have we have user permissions too, if that's something you guys are concerned about, where we can, lock down who can edit the library based off of their, permissions assigned to each user. So hopefully that helped to answer that question. It was kind of a long-winded answer.
That was a good one. Holy cow. Sorry, can you go over connector or manufacturer part assemblies? I tried to explain it in text, but I got a couple of comments about especially 38999s, mil-spec connectors. The best way I can describe it while Thomas is pulling this up is if you have an Amphenol connector and you order it from whoever you get it from, PEI Genesis or whoever it may be, a lot of times those parts that you get, you have to order 3 or 4 different parts, or maybe there's 2 different types of pins. So you can create a custom connector assembly of that. So you have your housing, you have your pins, 2 different sizes, your back shell, maybe it's a 90-degree back shell, 45, whatever it may be. But the housing could be the same for 15 different parts that you're using. So this is where a connection or a manufacturer part assembly would come into play. You can see here he's adding multiple parts, which leads into another question that was there, was he has the base component and he also has auxiliary or accessories to that. So I saw a question about connectors and there are pins inside that. Now in here, you don't necessarily need to show every single pin. You show the housing and all those are auxiliary parts. Those auxiliary parts are not going to be seen on your schematic. However, in your bill of materials, all that information is going to be available because you've added it here to that part. I pretty much answered the question while you showed your screen, so there you go.
Yep.
Let's see here. So give me a second. There's a whole bunch of questions.
Yeah, there is. I'm looking at them myself. We got about 2 minutes left. You've answered a ton.
Can you show the different symbols that are available for twisted pair, shielded, and stuff like that?
So just out of the box?
Correct. I mean, these are very generic and they can always be edited and manipulated as necessary. These are what the symbols look like for shielded pair, shielded twisted pair. And you would essentially, typical schematic, you would put those over there. Now, when you're drawing that out in the harness, it's not going to show them twisted like you'd see in reality where you're taking two of them and twisting them together. So that's just, you'd have to add an additional symbol as necessary or make a call out for that.
Yep. So, yep. So, I mean, go ahead.
Last one, cable lengths here is, how do you, if you're not doing cable lengths in 3D to capture the cable lengths, how would you enter the cable information, the length about cables? You might have covered that, but just to reiterate.
Yeah, I mean, it's still going to be a manual. We have text with leaders, so we could add a text with leader or add a text note to that to specify the length, but it's a static value that is manually entered once that length is determined.
Sorry, I'm trying to get a couple more questions in there. There's just so many in here. SQL, how do I set up SQL? Can you explain what happens if it's a standalone versus a network installation?
Yeah.
I got a lot of questions about SQL.
Yeah, so we are a SQL-driven database tool. So what happens, let's say, you want to do a single user local install. When you're installing the software, the download manager will also install a SQLite version. All of that information is put right there on your local machine. So you're running a SQLite database there locally on your machine that you would have access to. So SQL Express does come with the application. Now on the server side, it's just a matter of telling the application when we're installing where to put the SQL server, where to put the collaborative server. So we're specifying those to your server location, and then all the client machines are pointed to those particular servers and have access to the same database information. So again, software does come with SQL Express. If you already have full SQL, you can definitely integrate into an existing database in a new instance for electrical.
And the last comment here is, I've seen a lot of comments about installation. So my last comment before Thomas, if you have anything else, is feel free, please reach out to myself and Thomas. Please reach out to your resellers. I'm going to call them out right now. Tim, Brian, Jeff, I know you guys are watching because you're asking questions too, but the resellers are there to help as well. So if you have questions about installation, if you have questions about working from home right now, that was another topic I'm trying to cover here as well. If you're working from home and you're trying to get your network set up at home so you can still connect to your office while working from home, please reach out to your reseller. Please reach out to us. Thomas, is that document finished?
Yes, yeah, we'll be releasing a technical blog. It should go out this week, which definitely highlights the various scenarios that you will encounter working from home and the best ways to set up your application to interact with your engineering data. So yeah, that's definitely coming out on our corporate level blog here this week.
And the last comment I have is a lot of this was 100% of this was on the 2D side, the SOLIDWORKS electrical side. I know I answered a few questions regarding the 3D side, and especially something like length. So if you're interested in learning more about the 3D side, please reach out to us again. We'll be glad to cover a little bit more detail on what you would do if you need to connect to 3D. So.
All right. Well, thank you, JP. Thank you to everyone who attended today, and stay safe and stay well.
If you have your questions and I did not answer them, we do record all the questions, so we will be reaching out to you later on. I'm sorry, I tried to answer. I don't know how many questions I was just typing away for the past hour or so, but again, we will get back to you.
Yep. Thank you, and you all have a great day.